All right, this third part, I actually confused myself on in the second period on what exactly they're looking for here. But the question on the third part says the average rates of change found in 1 can be used to estimate the number of cars in the parking lot at time t hours for t greater than 8 hours. Will these estimates found using the average rate of change be less than or greater than the number of cars predicted by the model at t hours for t is greater than 8 hours? Explain your reasoning. So, for this, initially what I was wanting to do for this was, like, we found the regression in the very first part, right, part A. So I was wanting to, like, plug in 7 to that, and then plug in 7 to, we already got 7 right here at 16.3 repeating, see which one's highest, right? That is not what they're wanting you to do on this third part right here, really, ever. First of all, it's talking about using this for t is greater than 8 hours. So 7 wouldn't be a good number to plug into this because 7 is less than 8, right? So it's not the part they're asking us about. Also, while it will work, like it can help you understand what you're doing, to use a number bigger than 8, so you could plug in 9 or 10 or 11 and then compare it to your linear here, it doesn't guarantee it's every point. So what they're wanting you to talk about is like the shape of the graph here. So let me pull up my calculator because I think it should still have, I graphed this earlier. So what I did, actually, what I did here is I graphed that regression, and I'm going to get rid of that extra line there. I graphed that regression. So the shape of this, and actually let me fit my window. Let's go down to, let's make that y min like -2 so we see the x-axis. Now I'm just doing this to get a picture of what's happening, but this is what that regression looks like. It looks like this. It's eventually going to cross the x-axis here. If you want to see like where a point is at here, if I hit the trace button, it will have a little spider show up there. I'm going to do, for your sake, I'm going to go to my window, and I'm going to actually make the Y max bigger too. I'm going to make it like 30, just so it's easier to see the top of that graph. It gets behind the letters whenever you do it otherwise. So if I hit trace, it'll let me move that around. So the rate of change that we used was from 5 to 8, and 5 was right up there at the very top. So 5 was like right here, right? So we used the point right there at 5, and then we also used the point over here at 8. So if I go over here, well, let me type in 8. Yeah, it will. It'll show you 8's about like right here, right? So what we essentially did is we used like a line that went through those 2 points to predict instead of using the quadratic. All right. So if they asked us between 5 and 8, the quadratic gives you a higher number than the line. But they asked us about past 8, right? So past 8, which one is going to give you a higher prediction for this one? The red line that we've got here or the purple quadratic? Which one's going to be higher? It's the red because it's on top here, right? Between 5 and 8, the purple is higher. But over here, the red is actually on top. So the way he worded this, the estimates would be greater than the number of cars predicted by L of t because the graph of L of t is a quadratic with a is less than 0 and it's concave down, which means the rate of change is decreasing there. I think you could talk about, like, draw this picture and label, this is your, like, rate of change approximation, and then this one right here being your L of t, like that, and you could say something. You do need to say something about since L of t is concave down, for t greater than 8, the line used for approximation is above or greater than L of t. So, and then you use that conclusion, the average rate of change will give you a greater estimate for that. Okay, questions on that? For part C, I tried to think about this a little bit in second period. He gives 10.286 and then says the largest value of t is 10, and I don't like that. Because nowhere in the question could I tell that it was telling you to round. And what does t stand for in this case? It is your hours, right? So, can you have 0.286 of an hour? You absolutely can, right? You can have part of an hour. It would be just some minutes, right? So, a few seconds maybe. So, I don't like that he rounded that. Because the question doesn't tell you to. I would just say that the biggest number you can have for t is 10.28. The reason for this is, if we look at this graph again, let me go over here and make my x max a little bit bigger, is because after that point right there, 10.286, your graph goes down below the x-axis, and you can't have negative cars in a parking lot. Right? It doesn't make any sense to have negative values in this case for that. Now, if they had asked us, like, what is the largest number of cars this works for, you'd be looking for the y-coordinate of that maximum. It would make sense to round that because you can't have part of a car. But it doesn't really make sense to me to round that time, so I think I would leave it here. Okay, questions on that one? All right, let's go to the third one. That's this one, right, with the AB to the second equals 31 and AB to the 15th equals 136. So those are your two equations to start with. I would definitely use regression on this one because solving this by hand, this one is difficult because you have to do like a system of equations sort of thing. So just use the regression. A is 24.692 and B is 1.120. Everybody good there? All right, if we go down to the next part, your average rate of change should be 8.079 deer per year. I would just probably show 136 minus 31 over 15 minus 2 for that. For part 2, again, I probably would not have written it this way. I probably would have said 136 plus 8.076 times 4, because from 15 to 19 would be 4 years. Or you could use D of 2, and it would be 17 that you'd be plugging in there. Now, he does round this. I would do it this way. It doesn't specifically say to give a rounded answer, so I would do it this way. I would say 136 plus 8.076. I don't know why it's doing this weird thing. Times 4 equals, and you get like 168.3 something something. Does anybody have a decimal on that? 308. I would write down that decimal. And then, underneath it, I'd say 168 deer. Because if for some reason you weren't supposed to round, but you have the decimal there, your chances are better, right? So I don't like that he didn't write the decimal down right there. I'd write it down and then make your conclusion after that. Okay. For this one, it says this question is saying consider the values here for this wooded area. A little bit. Oh gosh, what have I done? I'm gonna skip to. Oh gosh. Okay, so for this one, it says, consider the values that result from using the average rate of change found in 1 to estimate the number of white-tailed deer in the wooded area. 4 times t equals p, years where 2 is between 2 and 15. Are these estimates less than or greater than the number of white-tailed deer? So if you think about this, you're doing an exponential, and it's exponential growth, right? So exponential growth, I hit something. There's a, oh, I know I did. No, I want this. Now it's gonna. Okay, so this is exponential growth. That means the graph is gonna look like this, right? And so we found what's called a secant line when we are going from 2 right here over to 15 up here, and we're drawing like a line between it. That's our average rate of change, right? So, in this case, is it asking us to look, and I could draw this on out, is it asking us to look below 2, between 2 and 15, or above 15? Between 2 and 15. So between 2 and 15, which one is highest, the line or the exponential? The line. So since d of t is concave up, that line, you could call it a secant line, lies above d of t, which is the exponential. Therefore, the estimates using the average rate of change for 2 less than t less than 15 will be higher than d of t on that same interval. This is another way you can word it for that. Does that make sense? And I'm kind of hoping that they'll ask us the question like they ask us in Part C. It asks you which one you're more confident about, predicting at t equals 8 or t equals 23. Whichever one's between the data is the correct one. So t equals 8 is between 2 and 15, which is where your data is at. So it is going to give you a better prediction than something outside of that range for that. I think those are easier than the other ones that they ask. Part C. Okay, questions? All right, before we put that away, I do want us to look at Part A of 2 and 4. Because last night I gave you ones where you could use the calculator to do the regression. But you can't always use the calculator to do the regression. On number 1, on the first one, you could use the calculator to do the regression because it was just a basic quadratic, right? AT squared plus BT plus C, basic quadratic. And on number 3, or the third one there, you could use a regression because it was just basic exponential, a times b to the t power. But if we go look at number 2, this is not a basic natural log function because for number 2, we got a plus b natural log of t plus 1. Normally, we just have a t there, not a t plus 1, right? So that means that we're not going to be able to use a regression for this. We're going to have to solve it by hand. We can use the calculator for any decimals that we run into, but we've got to like set up the equations and solve it. So, and the same thing is going to be true for number 4 in a little bit different sort of way. So let's look at what to do for this. So Mr. Passwater is on a fitness program. He runs his mile in 624 seconds at the beginning, and then after 20 weeks, 502 seconds. So if we get our points that go with that, that is going to be 0, 624, and 20, 502. There. So to write your equations, you are using whatever the form is that they give you. And in this coordinate, the x coordinate is your t value, and the y coordinate is your r of t. All right, so for that first equation, r of t is going to be 624 equals a plus b natural log of t is 0, so it's going to be 0 plus 1. And then for the second equation, you're going to have 502 equals a plus b natural log of 20 plus 1. On this problem, if you try to use a regression, you'll find out really quick that you can't do it because it is going to give you an error when you try to do the regression because you'll be trying to do a natural log of 0, which you can't do. Okay, everybody okay here setting this up? All right, so part 2 asks you to solve it. I'm going to do it down here because I'm going to run out of room. So if I've got 624 is going to equal a plus b, and 0 plus 1 is just 1, so that's going to be natural log of 1. What is the natural log of 1? What? Not e. It's 0. Natural log of 1 is 0. Because, think about it, if you got like x equals natural log of 1, you do e to the power, e to the power, e to the x equals 1. What's the only thing x can equal? That'll give you 1. Anything to the 0 power equals 1. Right? So natural log of 1 is 0. So 624 equals a plus b times 0, which means the 0 is just going to go away. The b is just going to go away. So a equals 624. For your b, what you're going to do is you're going to use the other equation, and you can plug the a in since you've already found it. So it's 502 equals 624 plus b natural log of 21. And so you need to subtract your 624 here, which is going to give you negative 122 equals b times natural log of 21. Natural log of 21 is just a number, right? You can type it into the calculator to give you a decimal if you want. Natural log of 21 is 3.044. So we're just dividing both sides by natural log of 21. So if we do 122 divided by natural log of 21, we will get 40.072. So b equals 40.072. So if you see one where you can't do a regression, this is what you're going to do. Now, every one might be a little bit different, but you want to try to solve, ideally solve for A in one of the equations, plug it in, solve for B in the other equation. That's what normally happens. Sometimes you got to do a system of equations. Hopefully, if you have to do that, they'll give you one we can do a regression on. It'll be easier. Okay, I'm not going to do the rest of that question. I just wanted you to see that part, what you would do if you can't do it with the calculator. I want to do the same thing for the last question that you've got there. It's got this piecewise function, because it is also going to be different. You should, if you see something like this, you should know right away, no regression on this one, because there is no piecewise regression for something like that. So this one's going to have to be done by hand. Mr. Passwater missed a day of school. A rumor began to spread that he had won the Powerball lottery and moved to Japan. Initially, 7 students knew about the rumor. They were the ones that started it. After 2 hours, a total of 15 students had heard the rumor. After 6 hours, 67 students had heard the rumor. The number of students that have heard the rumor can be modeled by the piecewise function R given by this equation. So A, again, is going to ask us to write 2 equations for this. Now, they actually give you 3 points. They give you 2, 15, and they give you 6, 67. What other point do they give you? They give you 0, 7. Now, that makes me think I could write 3 equations, right? But it only asks for 2. What's going to happen whenever you see something like this is probably one of those equations is going to be useless. So let's just write all 3 of them, and then one of them is going to be useless, and we're going to mark it out because it doesn't help us at all. So if I do 0, 7, should I use the top equation or the bottom equation? Top, because I'm supposed to use the top when t is between 0 and up to 6, not including 6, right? So I would do 7 times a to the 0 divided by 2 is going to equal 7. So I'm just plugging in that 0 for the t right there, and then it's equal to the r of t. Which equation do I use for the 215? Top or bottom? Also the top, because 2 is between 0 and 6, right? So I'm going to do 7 times a to the 2 divided by 2 equals 15. And then for the last one, should I use the top or the bottom? Bottom. 6 is in both places. How do I know it's the bottom instead of the top? Got that or equal to right there. So we're going to do negative 213.29 plus b times natural log of 6 equals 67. For right now, let's just leave all 3 of those. And we're going to try to use them to solve. And if one of them becomes useless, we'll just mark it out, because one of them is going to be useless here. So if we start trying to solve this for our part 2, I've got 7a to the 0 equals 7. What does a to the 0 equal? 1. So 7 times 1 equals 7. Am I going to be able to solve for a here? A went away, right? Is it true that 7 times 1 equals 7? Yes, so it's not false. It just doesn't help us solve anything. So I'd go back up here and mark that one out, because it's the one that doesn't really help you, and they only ask for 2. So let's go to the next one. Now I've got 7a. That's going to be to the first power equals 15. Well, this all I got to do is divide by 7. A equals, and they ask for decimals on this, so don't leave it as a fraction. I would hate for us to lose points for something like that, so 2.143. And then for the last one, we'll have negative 213.29 plus b natural log of 6 equals 67. We'll need to add 213.29 to both sides. B natural log of 6 will equal 213.29 plus 67 is going to give us 280.29. We're going to divide by a natural log of 6. And divide by a natural log of 6 here. We're going to get 156.433. So again, that one must be solved by hand for those. But they're not, if you get this equation set up correctly, they're not terrible to solve equations. So hopefully if they do give us one that you can't do a regression on, it'll be something like this. They could make it a lot worse, but I'm hoping that they will not. For that. Everybody good there? I'm going to put my 0 right here for this. Let's see here. We need to know the period of this function because that's the only way we'll be able to find the other points on the graph, right? What's the period for this function? So the period would be like highest point back to highest point. How long does it take? 15 seconds. This is 15 seconds. But if we're putting 0 right here in the middle, that does not mean we put 15 over here. What do we put here? 7.5. It's half. And then that would be negative 7.5 on this side. What number would go right here? It is 3.75. And if you must, go over to the side, do a little bit of division, right? Because you got to have that value. So 2 goes into 7 3 times. 3 times 2 is 6. Subtract 1.5. Actually, let's not put the point right there. We'll put it right here. So how many times does 2 go into 15? That'd be 7. 7 times 2 is 14. You subtract, you get 1. Bring down your 0. And 2 will go in 5 times. So you got 3.75 for that, which means this is going to be negative 3.75. So those would be all of our points. All right, so they are wanting us now to do A, B, C, and D. We have to use a cosine function. So there's different options for this. You don't have to do it one certain way. However, I think it is easiest, in this case, not to shift it left or right. Because cosine normally has a y-intercept where? Maximum point, right? Cosine normally looks like this. That's our maximum right there. That's cosine of x. This one, our y-axis is right here where t equals 0. This one intersects the y-axis at a minimum point. What can we do to make cosine start at a minimum instead of a maximum? Flip it with a negative, right? So what I would do, you're going to have like A equals, B equals, C equals, and D equals. On the like actual answer sheet for this, they've got a separate box over here for you to put those values so that it makes sure that you list them all. So I would not shift this left or right at all. I'd put a 0 for that C. And I would do the A. What would the amplitude be for this? Not 10. 5. Because it's just from the midline to the highest point. So it'd be 5, and I'd make that negative. And making that amplitude have a negative in front of it flips the graph. And that way you don't have to shift it left or right. And it's easier if you don't have to shift it left or right. What's D going to be? D is your midline. What's our midline? 6. Right there. So all of those numbers are pretty much just plugged in. Remember, B is the one we don't just plug in, right? So to get the period, you do 2 pi divided by B, and it gives you the period, which is 15, which means you need to multiply by B on both sides. 2 pi would equal 15B. We've done this so many times, you probably know it's just going to switch places, right? You get 2 pi over 15 for your B. Everybody good there? You can write out the equation with those numbers plugged in if you want, but it's asking for A, B, C, and D, so you don't have to in that case. Alrighty, let's keep going. C, it says to revert to the graph of, in part A, and we're looking from the t-coordinate of G to the t-coordinate of J. So on that graph, we're looking from G to J, which is this section right here. All right. Is it going to be positive or negative? It is positive. In fact, does it matter which section they give us? Is it going to be positive or negative? All of these are going to be positive because the lowest this ever goes is 1. It doesn't go below the x-axis here. So, we're positive. Is our graph increasing or decreasing? Decreasing. So positive and decreasing is our answer for that. B is what we're going to choose. Remember, on that one, you're just looking at the graph. For the second part, it's not asking you about the graph. It's asking you about the rate of change of the graph. And so the key to remember for that is if H is concave down, then rate of change of H is decreasing. And if H is concave up, then rate of change of H is increasing. So they're asking us about the rate of change of H. If we know about concavity of H, then we can answer this question. What do we have there? Is that concave up or down? Up. That's concave up. So now, when you're writing this, because I remember from this particular test, you want to be really careful. An interval is never increasing or decreasing. It is the function or the rate of change of the function, but not the interval. The interval just tells us the window we're looking at, right? It doesn't tell us anything else except for where we're looking. So don't say the interval is increasing or the interval is decreasing. That's going to be wrong no matter what question they have asked you. And I saw that several times. Instead, you want to say the rate of change of H is increasing on the interval or for the interval. Either one is fine. T to T1 to T2 because the graph of H is concave up. So the answer to that question is always rate of change of H is either increasing or decreasing. Or pick one of those on the interval from T1 to T2 because the graph of H is either concave up or concave down. So really, you could almost make this like a fill-in-the-blank kind of answer, right? It's all we're thinking about is this word right here can be increasing or decreasing, and these words right here can be concave up or concave down for that. Of course, you can word it differently if you would like, but if you like a formula for something, this will work every time. Okay, everybody good there? Let's do 1 and 3 on that for your assignment. You do not have to do number 4 unless you just want some extra practice. So 1 and 3 for that tomorrow.